Edexcel A-Level Maths, Pure Paper 1, June 2022, question 14. Given that 2 sine x minus 60 equals cos x minus 30, we need to show that tan x is equal to 3 root 3. So looking at our initial equation, we've got a sine with two values in there, and we've got cos with two values in there. So this tells us we're going to use our addition formulae to simplify this. And those are sine a minus b equals sine a cos b minus cos a sine b, and cos a minus b is equal to cos a cos b plus sine a sine b. We're going to put these into the initial equation, which is here, but putting x, we're going to use that as our a, and our 60 is going to be our b for the sine, and for the cos, our x is going to be the a, and our 30 is going to be the b. So putting those into those formula, we get that 2 sine x cos 60 minus 2 cos x sine 60 is equal to cos x cos 30 plus sine x sine 30. We can now put in our values for our cos and sine of the 60 and 30. So cos 60 is a half, sine 60 is root 3 over 2, cos 30 is root 3 over 2, and sine 30 is a half. Simplifying this by multiplying the 2's and the halves together on the left and just bringing those multiples to the front on the right, we get that sine x minus root 3 cos x is equal to root 3 over 2 cos x plus a half sine x. We're now going to bring the sines together on one side, cos is on the other, by subtracting the half sine x from both sides and adding root 3 cos x to both sides, which gives us a half sine x equals 3 root 3 cos x. We can now double both sides to get rid of those fractions, so sine x equals 3 root 3 cos x. Now if we now divide both sides by cos, we will get sine x over cos x on the left, which is equal to tan, so tan x must equal 3 root 3. For part B, hence or otherwise solve for theta between 0 and 180 degrees, 2 sine 2 theta equals cos 2 theta plus 30, giving our answers to one decimal place. So the hence or otherwise is the big clue for this one. This tells us we're going to use what we did in part A to help us. So the equation we've been given here is very similar to what we had in part A. Differences are that instead of x minus 60 within the sine, we've now got 2 theta. And instead of x minus 30 in the cos, we've now got 2 theta plus 30. But if we set these equal, so let's look at the sine. We've got 2 theta instead of the x minus 60 that we had in part A. If we set them equal to each other, now add 60 to both sides, we get that x is equal to 2 theta plus 60. And if we just double check with the cos, this is also true there. If we substituted this into part A, if we had x minus 30, that would now become 2 theta plus 60 minus 30, which is also the 2 theta plus 30 that we've got in part B. So all that's happened here for part B is that we've replaced our x with 2 theta plus 60. Now in part A, we showed that tan x is equal to 3 root 3. This is a much easier equation to solve. So we can substitute our 2 theta plus 60 into that, and we're now going to solve this to get our answer. So 2 theta plus 60 is going to equal the inverse tan of 3 root 3. We now just need to check for bounds. So theta is between 0 and 180. So to find our new bounds for 2 theta plus 60, we're going to multiply each side by 2 and add the 60. So 2 theta plus 60 must be between 60 degrees and 420 degrees. Our first value, if we put inverse tan 3 root 3 into the calculator, it will give us 79.1 degrees. Now remember, tan repeats itself every 180 degrees. We can just check the lower bounds. If we take 180 off of this, well, it's going to be negative. That's going to be well below 60. So 79.1 must be our smallest answer. So now we add 180 degrees to that to get our next answer, which is 259.1. If we added another 180, that would go above 420. So we've just got these two answers that we need. But this is 2 theta plus 60. So to solve this, we need to take away the 60, divide by 2 for both of those answers we've just calculated. Hence, theta is equal to 9.6 and 99.6.
If you've enjoyed this video, remember to subscribe to the Doing Maths channel to keep up to date with all the latest releases.